Hey, how you doing guys? It's Ilabella here. I do coding stuff on YouTube, chat description for all my information. I do all LeetCode problems. Make sure you subscribe to the channel, give me a big thumbs up to support it, and this is called maximum nested depth of two valid parenthesis strings. A string is a valid parenthesis string denoted VPS if and only if it consists of parenthesis characters only. And it's the empty string, or it can be written as AB, A concatenated with B, where A and B are VPS, or it can be written as A, where A is a VPS. We can similarly define the nested depth S of any VPS as follows. Depth an empty string is equal to 0, depth A plus B is equal to maximum depth A, depth B, where A and B are VPS. Depth, you can see right here, is equal to 1 plus depth A, where A is a VPS. For example, an empty string, those strings right there are VPS with nested depth 0, 1, and 2. And those strings are not VPS. Given a VPS sequence, split it into two disjoint subsequences A and B, such that A and B are VPS, and A.length plus B.length is equal to sequence.length. Now, choose any such A and B such that maximum depth A, depth B is the minimum possible value. Return an answer array of length sequence.length that encodes such a choice of A and B. Answer at the position of I is equal to 0 if sequence at the position of I is part of A, else answer at the position of I is equal to 1. Note that even though multiple answers may exist, you may return any of them. Well, let's look at those examples. We got those strings. You can imagine, like points, right? You can think of those like points. This is the first point. An open parenthesis is equal to -1. Close parenthesis is equal to 1. -1 plus 1 is equal to 0. We got 0 and 0. Then -1 and 1. We got right here 0, and we got 1 and 1, and right here 0, 1 and 1. Here -1 and 1. We got zeros. Next we got 0. And right here 0, and 1 and 1, because -1 and 1, 0. The size of sequence is greater than or equal to 1 and is less than or equal to 10,000. When we can do that, go for it. All you need is n, which is the length of that sequence. We maintain an array of the type integer. The length of that array is equal to n. We are looping through that sequence. We start from 0, I is less than n, I plus plus, and at each iteration, by the way, you use the method right there, the length, and at each iteration you set up the value at the position of I. In the case when the character at the position of I, the current position into that sequence, is equal to an open parenthesis, then you you say the current position bitwise and 1, otherwise 1 minus the current position bitwise 1. This right here, bitwise and, is more important than minus. So we do this action and then we subtract. Finally, we return an array. That's it. Let's run this code. Accepted, good. Let's submit. Success. Great. Let's look at that example real quick. We got those parentheses, the sequence. That's 0 based in Java. We start from 0, 1, 2, 3, 4, 5. We get n, which is 6. The length of that sequence, an empty array. You know, starts from 0, 1, 2, 3, 4, 5. You know, bitwise AND means that 0 and 0 is equal to 0, 0 and 1 is equal to 0, and 1 and 1 is equal to 1. Yeah, so we start iterating through that sequence. We are at the position of 0 right here. We can see that this character is equal to that parenthesis, so we set the current position, which is 0. 0, you know, binary representation, and 1, which is this right here, is equal to 0 and 1 is equal to 0. 0 and 0, 0, and 0 and 0, 0. We got a bunch of zeros. We got 0. We set up to 0 at the position of 0. Yeah, so we increment I by 1. We are at the position of 1. Here that's the same. 1, which is, you know, right here, 1 and 1 is equal to 1. We update, we set up the value to 1 right here. Then we increment I by 1. We are here. Is not equal to this parenthesis. We are here. The current position, which is 2 right here, means that we got 1 and 0. You can think of that, you know, like binary representation means that base 2 raised to the power of 0 raised to the power of 1 and 2. So in order to count, you know, in order to know the value, you should look at ones and at those positions where those ones are. Right here we can see that 1 is at the position of you know, right here, 1, the base 2 raised to the power of 1 is equal to 2. So 2, you know, 0 and 1 is equal to 0. Then 1 and 0 is equal to 0. 0 and 0 is equal to 0. And 1 minus 0 is equal to 1. We set up to 1. We increment I by 1. We are here. And you know, 3, which is right here, 3. 1 and 1, we got 1. 1 and 0, 0, 0, 0, 0. We got 0 right here, 0 and 1, and we got 1. Then we increment I by 1. we are at the position of 4, and 4, 4 means that we got 2 zeros and 1 right before them. So 0 and 1 is equal to 0, 0 and 0, 0, 1 and 0, 0. We got 1 minus 0 is equal to 1. Next we increment I by 1. We got 5 right here, the position of 5, and 5 means that we should change that digit. This right here, we got 4, right? 4 plus 1, the base 2 raised to the power of 0, 1, 2, which is 4, and the base 2 raised to the power of 0, which is 1. 4 plus 1 is equal to 5. 1 and 1 is equal to 1. 0 and 0, 0, 1 and 0, 0. 1 minus 1 is equal to 0. That's it. The time complexity for this solution is equal to big of n, linear time. The space complexity is you could say that it's linear, but we got predefined length of that array, so I would say that is constant time. Yeah. Thank you guys for watching. Leave your comments below. I want to know what you think. Follow me on social medias. Follow me on Instagram. Add me on Snapchat. And I'll see you next time. Have a good one. Bye.